Okay, let's begin again. Okay, so if you have n plus 1 distinct points, you will have n plus 1 polynomials for these values. Okay, this this is what we're going to study. Okay, so LIX, sometimes some book has IEX or anything. Okay, interpolation for they can use IE, or L is for Lagrange's, any. Okay, so according to that you can understand. So pi n plus 1 point. So x minus. So what is the things you are noticing here? Did you notice anything? Just to seeing this, did you notice anything? Just can you watch carefully and tell me whatever you have find from this? I mean, just in this, did you notice anything that can be explainable? Okay, or is that just like that n plus 1 point? So what is happening actually? So if you understand only, you won't, forget. So that's what I'm telling. I give you 1 or 2 minutes. Just write down and just watch it 1 or 2 times and tell me how you can interpret this equation. Can you type your answers? Just I don't want the full sentences. Just tell me what you are understanding in this, what you are finding. So in this equation, you can say yes, this is for x, this is for xi. Then next equation, what is happening? Is that same in the numerator denominator, or anything a small changes or anything something? No one notice anything? Okay. 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 One person noticed something. What about others? Okay. Good answers. Can you watch some more? So if you watch it some more, 1 or 2 times, and if you understand yourself, you don't need to memorize this. The examination or any purposes will be automatically you can write without memorizing. So that's what I am giving some time. So can you go through again, and can you find some ideas? Okay, I got 3 answers. Yes, good answers. What about others? I'll leave you 1 more minute. Others also, please look through. If you find anything else, please let me know. Mm, okay. What else? Let me read your answers, okay? One person has answered me x minus xi term missing in numerator and xi minus xi missing in denominator. Okay. Okay. Can you see that now? Something missing, no? In between. Here. See, we have the xi minus 10, xi minus terms, then xi plus term. What happened to the x minus I? So we don't have. Did you watch it? Okay, next one. Other one says in denominator x replaces by xi. Yes, good. All the in the numerator all are x value in the first place. So the next one in the new denominator everything are xi. That is also okay. And yeah, other answer is yeah, same answers. Replace x by xi. And one more person asked said x is multiply n times. Oh, that is okay. All right. So the thing is, so as you said, in the denominator, we don't have xi minus xi now. What is xi minus xi? At least answer for this one. Why others are too silent? I don't know. I am getting, okay, I'm gonna mark the people who are answering me. Okay, so that is also countable for some marks. Let's see. Okay, so many people are just being silent, or I don't know whether they are available. Yes, good. This is 0, no? So 1 over 0 is what? Yes. So is there an infinity number in the real world? Can we use for anything? No, no. So there's no use with the infinity. Okay. So you have to be careful. Okay. When you are writing also, okay, in the examination or any purposes, that is one point you have to keep it in mind. So you have to know, yes, I don't get x minus xi in any point. For example, x1 minus x1, I won't get. Or x2 minus x1 in the next time. I mean, L1, something x1, no. L2, I need to go for x2. Okay. So in that sense, I won't get something like this in my denominator. I mean, yeah. Okay. Also, in the numerator also, the same terms, whatever the x minus xi won't come. Why? Because that xi only we are gonna put here, no. Okay. For the first one, Li1, I'm going to use my xi. Okay, the x is anyway, but here I'm going to use x1 for if it is I is equal to, I mean, for example, 1. Okay, I can't use x1 minus x1, no. So this won't come. Okay, so according to that, it will be changed. Okay, so we'll see later. But this is what it's happening. Okay, so simply if you say something about it, that's what it is. Okay. We don't, if you are considering the ith term, the xi terms in the numerator or denominator won't come in the calculation. Okay. So we need to leave it and calculate the rest of the value. Okay. For the x naught, I mean, if you are taking I is equal to 0th value, x naught won't come in the first, I mean, numerator, but the denominator, this will be x naught minus x naught. So it won't come now. So it will go to x naught minus x1, x naught minus x2. Second, if you put I is equal to 1, so x1 minus x1 terms will be cancelled. So x1 minus x naught, x1 minus x2. So it will be jump here to here. Okay. So that's the small things you have to keep in mind. So it is a general idea. Okay. So we'll see when you are doing exercises, it will be understand. Okay. So I values will be 0 up to n. There are n plus 1 points. Okay. So each after you find, for example, L1x, L2x, L3x, you will find something now up to n. If it is n plus 1 point, you will have n plus 1 polynomial like this. This is one of the polynomial, second polynomial, third polynomial. So since, okay, one of the person said, here we are having x multiplied n times, no. So you will have something x to the power n, something polynomial. Okay. So what is the polynomial actually? A naught plus a1x, a2x squared, something like that, no? So likewise, one of the polynomial you will have for L1. Similarly, L2. Similarly, L3. Okay. So these kind of polynomial. Okay. So let's continue. After this one, okay, each of these polynomial is of degree n. Okay. So for example, if you are having, n plus 1 numbers, no, n plus 1 points. So you will have the n plus 1 polynomial, but this polynomial, for example, let's say my Pn, okay, n is equal to 3, 0, 1, 2, 3, okay. So you will have, this one will be x to the power cube. This will be x to the power cube. This will be x to the power cube plus something, okay? X squared, x minus 1, x, and then a constant, okay? You know the 3-degree polynomial, no? Something a0 plus a1x, a2x squared. Is that here or this one? You have to go up to here, no? Less than or equal to n, okay? So in that way, you will have all these polynomials will be in the degree n, okay? And these polynomials are called Lagrange polynomials, okay? For the points, these points, okay? This L1, L2, L3 up to Ln, let's say n points, okay? You will have the degree n polynomials, n plus 1 polynomials, okay? Now after that, okay, after you are finding this polynomial, you have to go to do some extra works, okay? It means after that we have to multiply these. So we are not still finished our Lagrange interpolation polynomial, okay? In that sense, we need to find a polynomial which has y0 value we can find, no, if it is x0, if they have give you the function of f of x, okay, xi, let's say xi values. So in that way you can find the yi's value, no. So that for if you are considering I is equal to 0, the y0, L0 x. Okay, whatever you are, so what is this one says is, so you will have L0 x. Okay, that's what. Okay, you have to put that polynomial here times y0 plus again you have to add the next polynomial times y1, next value of y. Okay, likewise you have to add all the values of polynomial times of y value, okay, which is the sum of the polynomials. So after that, see here, this is for example this polynomial's nth degree, okay, this will be some value, no, only a constant, no, this will be one of the constant times xn, let's say for example this is also constant on xn. So if you add all these, you will have something, okay? If it is, let's say, x cube for one polynomial, then minus x3. Then this will be cancelled out, only x squared will come, okay? So they put the polynomial, the sum of the polynomial may be equal to n or less than n, okay? So in that, so when we are adding, maybe sometime it may cancel out, no? So by some constant. So we can write this polynomial as Pnx equal to summation of this Li, this one is the Li, no? Lix times yi. Okay, so commonly we can write like this way. So you can, bracket here. This is what Lix times yi summation. Okay. Okay. Sometimes in some book they use for the Li they use ii. Okay. For the yi they use fi. You know these things now. They can use any variables, okay? Okay, that's all the introduction about the Lagrangian method, okay? So let's go for one note, okay? So I just put the heading because I didn't type yet. So I will write it in the board. First of all, you put the heading under the note, okay? It says existence and uniqueness of the Lagrange interpolating polynomial. So we have to make sure it is exists as well as it should be unique. So for everyone, we should have same answers, no? So there is a uniqueness also there. So we can check it. So put the note as well as the heading. So I will continue in the whiteboard. Okay. Let's start to write. Okay. Write with me. So as we have our Pn of x, that's what we have seen at last. I is equal to 0 to n. Okay. I can write like this. L of x times y I or fi. Okay. Anything. So in this we have which is equal to, okay, this Li x j, let's say. Okay. If it is 0, it means for the x value, if you put the xjth value, okay. For example, if I am considering my I is equal to 0, if I put my Li, okay, L0, if I put x of 1, what will happen? Can you imagine? It will be 0. I'm telling it will be 0. So go back to the, equation of Lix. What is that? Actually, it says x minus. So you don't have the ith value, no, here. So you can have x naught, x1 up to xi value. You have to, omit. Okay. So I minus 1. Okay. For example, let's say I have only 0, 1, 2, only these values. Okay. So if I put L naught of x, so I need to write x minus. Can I put x naught? This is my x naught value. Okay. This is my x1 value. This is my x2 value. Okay. So can I put here x naught? If I am starting with L naught, I can't put x naught now. So whatever the I value I am defining, I can't put here. Okay. So if I am defining I is equal to 0, we won't have x naught, but we will have x1. Okay. All the other value will become x minus x2. Okay. Because 1, 2, 3 values. So I have only this. Okay. According to the question, it will change. Okay. But here, what I have, the same thing I can copy this one, x2, this one, x1, same. Okay. But here, for the x value in the denominator, I need to put the x value of this one now. If it is I value, I need to put xi. So if I put I is equal to 0, I need to put this one. For example, 0 minus, then 0 minus x2. Did you get that? Okay. What if I put for the x naught, if I put, whatever the value I'm finding, if I put the different value here, because different value will be there, no? For example, if I put for the x equal to, if I put x1, for example, so L naught of x1 will, what will be happen? So here I need to put x1 now for the all the x value. They ask you to put the x1. So already x1 there now. So x1 minus x2. Okay. Again, this one, okay, minus x1 and times minus x2. See what will happen, x1 minus x1, this will be 0, no? So whatever the value you are finding, it will be 0. Good. Doing it, lectures. Okay, 0. Did you understand? So if it is 0, if you put 1th value, it will be 0. If you put second value, in this case, it will be 0. So you have, if you put any value, xi value, which is different from the I, okay, where I not equal to j, you will have the 0. But what if xi is equal to xi, the same value? For example, let's say j, but I have I is equal to j. So same value I don't have no. The the numerator I don't have, or denominator. So I will have the 1. Okay. So this is we also called Kronecker delta, some kind of, isn't it? You may seen somewhere. Okay. So I'll write again the notes. Okay. The thing is Lixj. Okay. Give me a second. Okay. Xj. Okay. Will be 0 if j. So if I'm using I and j different way. Okay, if j not equal to I, okay, I have explained you. I'm just writing the note what you have to write. Okay, if it is say j, but if I is equal to j, you will have 1. Okay, so this is what you have to write after that. Okay, hope you understand. Okay, you can try again. So if you put the different one, you will have, because the different one already there in the numerator, no? So somewhat it will be minus x1 minus x, if I put x1, this one 0, then somewhere I'm just omitting the 0th value. But 1th value, 2nd value, 3rd value, all will be there. So whatever value I put, it will be automatically will be 0. But I'm only putting the same value now. The same value I don't have in my numerator. So if I put, it won't do anything. Okay, it will give us a 1. Because why it is 1, for example, as I said, 1, 2, okay. Let's say 0, x naught, okay. So I don't have a x naught now. X minus x1 will be there. X minus x2 will be here. In the new denominator, I may have 0 minus x1, 0 minus x2. That is not a problem, okay. So if I substitute x equal to x naught, what will happen? I'll put here x naught, here x naught, isn't it? So, this will be 0. This will be 0. See, same things coming now. So, it will be, you can cancel, you can get 1. Okay, that's what it means. Okay, so you have to keep it in mind, these things. Okay, so you just understand yourself again also. We can see that some examples, so you will understand more. Okay, let me continue first of all. Okay, so now you can say now, so please write down. So our P and X, so you can put Pn or P, which is equal to, we know our final, equations, for example, y naught, L naught, xi. Okay, if I put xi, I have y1, L1, x1. I can continue, I can have yi, li, x, I, this one I, okay. Plus it goes up to yn, okay, ln xi. Okay, so as I said you, if it is, okay, so if I put xi, okay, so 0 term in the first Lagrange polynomial, if I put xi, there's no xi no. So as I said, if you, this, okay, I'll take one more different color. Okay, so as what I said you, this point and this point different one, you will get 0. So whatever you are multiplying, you will get 0 now. So this also, this is 1, this is I. So I will get 0. So I need to go up to here, I. So no problem. Same one, isn't it? So this one will be 1. So I can put yi times 1. Okay. So all the other term will be 0, 0. Okay. Up to 0. Did you understand? That's what I gave you that one. So this part and this part different one, you will get 0. So this part and this one same one, you will get 1. Okay. So finally y. So what I am concluding here? So my polynomial, Lagrange interpolation polynomial will be equal to yi. So we are getting some polynomial which is approximately equal to our actual value. Okay, so we can equate. That's what we are doing now. So for example, if you have, let's say x values are 40, 45, 50, something like that. Okay, and 50, 55 also. Okay, or different values. Say if this for 48, this for 50, this one for 59. Okay, as I said, this will be a different case. No, unequal points. So what if it is, for example, what is the value of, so yi is what? F of xi, no? So if you put x equal to 42, you will get somebody. So these values they have given. Okay, they already given, or they have given you the function. But what if, for example, if I put xi is equal to 48.5962, something like that, something inside, but it's not, it can't be find, no, that's why we are using these values. We are finding something approximately equal to this fx value. We are finding one polynomial. Then if you put this value, whatever the value we are putting, we can find but y. Okay, that's what our purpose of study this one. Okay, so hope you understand. So we have derived something Pn xi is equal to yx. So what you can conclude from this? So I'm just trying to prove this has these polynomials are exist, isn't it? So that is our note now. That is what we are doing. We need to find first of all the existence as well as uniqueness. So I'm just trying to show you the existence part. Okay. Okay, let me continue. Okay, so after this one, write down P of xi, Pn of P, just everything. Okay. Okay, so yi. Okay, so this is true for I is any I, isn't it? We are just finding for general terms. So we can say this is true for any I. Okay. Also is polynomial. So this Pxi also a polynomial of degree less than or equal to n. That is also we have proved. Okay. So from this we can conclude. Okay. Hence Px is interpolating. I told you the definition. Okay. Interpolating, we can find the value inside the interval. Okay. Px is interpolating polynomial of let's say f of x or yi, anything. Okay. Denote interpolation polynomial of fx. That's all. Okay. We can denote. I think I have written that one, so I don't need to write again. This shows the existence of interpolating polynomial. So include Lagrange. Okay. Lagrange is the person's name, so you have to use the capital letter L. Okay. So Newton, Lagrange, Gregory, these words are mathematicians' names. So the name, you have to start with the capital letters. Okay. So you use that one. Okay. So we have proved this is existence. Okay. Okay, let's hope you have written. Let's prove the uniqueness. Okay. So if you don't write, please take a screenshot or anything. Okay, let me continue for the uniqueness proof. Okay. So next one, to prove the uniqueness, let P and X, and so how to I mean, you may see in the group theory and the courses. So if you wanted to prove there is one only, okay, you can take two count example. For example, you can, if I wanted to say it is same, okay, one only, you can take two. Okay, for example, y1, y2, and what you have to prove is y1 is equal to y2. So whichever the case you prove, if it is equal, the two general idea you have taken is equal, then you can say only one is there, no? Okay, our meeting again gonna finish. So I need to go a little faster. Okay, let's make it faster. So that's why I'm gonna take 2. Okay, Q and X. So let P and X as well as Q and X are, sorry, interpolate for the same questions. I'm taking 2. Okay, P and X, Q and X. So write down the Q correctly. So interpolate fx at the points x0, x1, x2 up to xn. Okay, xn plus 1 also, because since node you can go up to. So I think okay, let's go distinct points. Distinct points. Okay. So if you are taking two interpolations, therefore P and Xi I have found. So we have proved earlier, no, the existent case P and Xi for the Lagrange interpolating, this is equal to Fi over Ya, for example, Ya. Okay. So also if I take first of all Q and X, that is also I can prove Yi, no, Y. I can say Q and X in the case of Li X J, I will have zeros, and the other one, so it will be obey the same procedure, no? This is also yi, for I is equal to 0, 1, 2 up to n. Okay, so both are equal, no? I mean not equal just now, I'm just saying. Okay, so in the definition of Lagrange interpolation, if all the other term will be 0, the same term will be so I have proved this one. If I take this one also, I can prove this one. Okay, now continue. Consider one hx, okay, which is equal to Pnx minus Qnx. Let's see we can find any error, difference between these two. Okay, that's different. I'm going to take as a hx. Okay, here hx is a polynomial of, that is also degree less than or equal to n. Why? Because this is degree less than or equal to n. This is, so degree n. So if I take away, sometime it may be equal, sometime the cancellation comes and equal, no? Yes, or less than equal, okay? Because Pnx and Qnx are degree n, okay? Okay, now also h of xi, if you put x equal to xi here, you will have here, what you'll have? Pn of xi. So whatever you are having the x, you have to substitute xi, no? Xi. So what I told you, the earlier one. Okay, I think, yeah. See, Pnxi, yi, Qnxi, yi. So, give me a second. So here, this will be yi, this will be minus yi. Then only I can get 0, no? For any I is equal, I is equal to 0, 1, 2 up to n. So I get h of xi is equal to 0. So write down please. This shows that hx vanishes. Okay, vanishes means it is cancelled out. So vanishes at the last point. For example, n plus 1th point, last point. Okay, distinct at n plus 1 distinct points, but hx is a polynomial of degree less than or equal to n. Okay. So this hx is vanishes. So from that you can say Pnx. Okay, so I'll write in the next line. So if it is h is equal to 0, this is equal to this one, no? So that's what we are gonna. Okay, so I'll write here because our meeting gonna finish. Okay, so from this, after this one, please write down here this one. Pnx equal to Qnx. Okay. So please write down. Hence, interpolating polynomial is unique. Okay. Hence, this polynomial is unique. Okay. Interpolating polynomial is unique. So we have proved the uniqueness also. Okay. So that's all about the note. Okay. Yeah. So now we can start to do some examples, so you will understand more. So if I ask you to, prove the Lagrange's interpolation polynomial uniqueness and existence, so you have to do all these, whatever I have written. Okay. So you have to understand this concept also. Okay, let me go back to the okay, we have to have some examples. I have creating one wait, this homework quiz, but I'm not yet finished, so second. Okay. Okay, I'll write the example. Okay, let's try until the meeting close. Can you see my window?
Yes, ma'am.
Yes. Okay. Please write down this example. I will type the homework quiz and I will send you later for all the question, but just do one or two questions here. Okay. Example 1. Just write down. Just write yourself. Find the interpolating polynomial. Find the interpolating polynomial in Lagrangian form. Lagrangian form for the data. Okay. Find the interpolating polynomial in Lagrangian form for the data. So this is how the question will come. Sometime, this is how they will tell you which way you have to do the questions. Okay. So in this question, they wanted you to use the Lagrangian method. Okay. So let's use x, y value. Okay. Or you can use f of x. Okay. So sometimes they may give the function, or sometimes they may give the table. Okay. So minus 15, this is minus 4, 0, 20. See, minus 1, yeah, this is not in equal, no? This has one difference. This has two different. This has 2, 3, no? 1, 2 different. So this is not equal, okay? So this is what you have to find out. Okay, not equal. So we have to use the Lagrange method. No. Okay, so okay, can you just, in meantime, can you try this LMX equation and also I can continue in the next meeting. So I think meeting gonna finish soon. Just start to work and I will join.